Okay, let's see how I did with this. A parallelogram has sides measuring 23.8 meters and 35.3 meters. Remember the opposite sides, which I've matched in the same colors, are the same because it's a parallelogram. Now, the height corresponding to the 23.8 meter base is 9.9. I'm going to rotate this so it's sitting on that base so that you can visually see it a little bit better. Okay? So if I rotate that, and remember it's not to scale, so don't worry about whether the measurements are correct or not. Okay? Then you would get a height of, and I will do this, let's see if I can do this height like that. Okay? Would be, they say it's 9.9. Okay, because we've got it like sitting on this base, and so this is the height. And remember, this is, if I put this as kind of like a dotted line to say we could extend that out just so that you can see where that side would go to, then we end up forming a 90-degree angle with it. Okay, so that height is that. Now find the height to the nearest tenth of a meter corresponding to the 35.3 millimeter meter base. So the first thing we need to do is this parallelogram. We need to use the formula for parallelogram, which is the base times the height. And we need to find out what's the area. So let's do that first. Excuse me. We could say 23.8 times 9.9 equals, let's calculate it out. And we get 235.62 meters squared for the area. Okay? Now, that's essentially what we need to do in the other direction. We need to say, okay, well, then if we were to rotate it back again, and let me see if I can lock all this in, just to, okay. Oops. That's fine. I'm going to do that anyway. If we were to rotate it down so that we had this base, then there's another height right here corresponding, oops, this side. Thanks for your patience as I get this right. This height, which corresponds to the base of this right here. Okay, forming a 90-degree angle. What would that height be? That would go 35.3 times what? So we'll say 35.3 times, and let's call that x, that missing length that we don't know, times x is going to be equal to the area that we already know right here, even though that's all kind of janky and sideways. We know that it should be 235.62 meters squared. Okay. Now we need to divide both sides, of course, now by 35.3. To find out what x is, and then we'll find that x is equal to, and what do we get when we do 235.62 divided by 35.3? We get 6.67. This is to the nearest tenth of a meter, so if it was 6 point approximately equal to 6.67, and we were rounding it to the nearest tenth, we look here, is that 5 or higher? Yes. So the 6 goes up to a 7, so 6.67 becomes just 6.7. Do we see that answer? We do. It's right there, C. Okay. So I don't know if I can shrink this down again. Let's see how I do in terms of that. Oops. Well, I'll just leave it at that. I'll just leave it at what we talked about, and hopefully that makes sense to you. And actually, I'm going to go one further, and I'm going to continue this just a second. Let me copy this, and I'm going to paste that in. I'm just going to talk about it one more time. You saw it visually how that looks, but we could mathematically do it this way as well. You could just say, okay, we've got those two measurements. The height corresponding to the 23.8 meter base is 9.9. So we know that to find the area, we would do the 23.8 meter base times 9.9. Okay, and then they say find the height corresponding to the 35.3 base. Well, we know that we're going to do the height times that, so we could say that the height there times that, and that's essentially just the math problem that we do. We know the height corresponding to the base, so multiply them together. Multiplying those together, you get 235.62. And then you know that that base of 35.3 corresponds to a certain height that will give you the same area measure. So we can then divide both sides by the number in front of h. And you get h equaling, as I said, approximately equal to 6.67, which again, if rounded to the nearest tenths place, and that is a fiber higher, bumping the 6 up to a 7, we would get 6.7 meters is approximately equal to the height. Okay, so if you understand what you're doing, you can do that without any illustrations, where you essentially say the height that corresponds to the base will multiply together to become the area. And then this height, which we don't know because we're finding it, corresponds with this base. So we multiply those together. That's here, and that 2 in blue are there.